Look past Neptune, beyond the orbit of Pluto, and you reach the outer edge of our solar system. Out here, 45 astronomical units from the Sun, floats the most distant object humanity has ever visited, Arrokath. On January 1, 2019, NASA's New Horizons spacecraft slipped through this darkness and executed a flawless flyby of this tiny, icy world. Out in the Kuiper Belt, the environment is intensely hostile to change. Temperatures hover near absolute zero, and the Sun is nothing more than a particularly bright star in the black sky, offering almost no heat or radiation. Because it sits so far from the violent heat and gravity of the inner planets, this frozen expanse has acted as a perfect, undisturbed time capsule since the earliest days of the universe. The images beamed back to Earth reveal a bizarre structural anomaly, a 20-mile-long object shaped like two distinct bulbous spheres, fused at a narrow neck. This delicate shape stands in stark contrast to the physics of the Emmer solar system. Near the Sun, rocks travel at tens of thousands of miles per hour, shattering into glowing debris when they meet, the same violent process that carved our moon out of the early Earth. Yet here are two fragile spheres that manage to collide and stick together perfectly without breaking into pieces. This structural puzzle suggests that a different, much quieter mechanism was at work during the formation of these distant icy bodies. Arrokath belongs to a group called Trans-Neptunian Objects, or TNOs. This is a vast, thinly spread population of icy bodies, living quiet, completely isolated lives deep in the outer solar system. For decades, this region was a blank spot on our cosmic maps. It took a painstaking search by astronomers David Jewett and Jane Liu, staring into the dark abyss, to prove this massive population was there. The architecture of this entire region is dictated by Neptune, whose massive gravitational pull acts like a cosmic traffic cop, enforcing strict orbital lanes. Because these objects are locked into these wide, regulated paths, they can orbit for millions of years without ever crossing. Neptune effectively prevents the chaotic, high-speed collisions that define the inner solar system. When the two parent lobes of Arrokath finally met, they didn't crash head-on. Their synchronized orbits meant they simply drifted together at a matched speed. They bumped at walking pace, generating a highly localized point of friction exactly where they touched. The surfaces of these lobes are packed with volatile ices like water, ammonia, and nitrogen. At the exact point of contact, that friction caused a brief, localized melting of those ices. In the near absolute zero of deep space, that melted water and ammonia flash froze in seconds, acting as an instant structural glue. Arrokath is a literal freeze frame, two independent bodies caught permanently mid-merger, bound together by their own icy adhesive. Once that icy bridge formed, nothing else happened. Arrokath has sat in the freezing darkness, completely undisturbed, for over 4.5 billion years. You won't find this kind of physical preservation anywhere near Earth. The inner solar system is a meat grinder. Solar radiation boils off volatile ices, planetary gravity tears structures apart, and constant asteroid impacts pulverize them. Out in the deep freeze of the Kuiper Belt, those destructive forces simply don't exist. That extreme isolation makes Arrokath an unparalleled, pristine physical record of the exact materials that built our solar neighborhood. Finding an object this fragile intact proves that planet formation did not rely solely on destructive impacts. It physically confirms the theory of gentle accumulation. Planets can gradually grow from tiny seeds through slow, sticky collisions that build mass without destroying it. Long before the violent impacts that shaped the fiery early days of Earth, its very first seeds were likely planted by this same quiet accumulation of ice and dust. Reaching Arrokath allows us to look 4.5 billion years into the past, offering a direct view of the exact moment our solar system was born.